Welcome to the micro lesson on determining domain and range of a linear function given an equation. So our first problem in number 1 is asking for the domain and the range of f of x equals 2x minus 7. Remember that f of x is another way to represent y. And then if we look at our equation, we can see that our equation is already in y equals mx plus b format. So we know that negative 7 is our y-intercept, and we have a slope of 2. Since I've already been given an equation, I'm going to go to my calculator and I'm going to type in my equation. So let's type in 2x minus 7 and hit enter, and I can see my the graph of my line. And so this line extends infinitely to the left and to the right and up and down because it has an arrow on both ends. And so if I was to draw the graph of it, I would be drawing a graph with an arrow on both ends of my line. And if we're doing that, that means that our domain and range are inclusive of all the numbers on the x and y axis. And so if any number on the x and y axis would make my linear function true, or could be a point on that graph, then we call that all real numbers. And so you can just write all real numbers. I'm going to abbreviate it here. You might also see a really fancy R, kind of like that. Sometimes they do that for all real numbers, or they do it in cursive, but all real numbers would be your answer for both your domain and your range, because this is a linear function that is extending infinitely in both my x-axis direction and the y-axis direction. Let's look at our next problem. This problem says, what are the domain and range of y equals 52? Well, I have y by itself, and if I look at the pattern mx plus b, I can see that I am missing a slope and a y coordinate for this particular function. Let's pop over here and look at the graph of this function. So let me go here and let's see. I'm going to go to graph. Function. And let's graph our function. Let me make sure I get the right. And so it was 52. And so we're just going to type in 52 exactly the way we see it. And then I'm probably going to have to make this 75. That way I can see my line. And there's my line right there. And it's a horizontal line, which means I have a slope of 0. But you'll notice that every single point, every x point, if I match it up to my function, has a y coordinate value of 52. So when we look at a horizontal line, it's important for us to remember that our domain for a horizontal line, because I am extending infinitely in the left and the right, is going to be all real numbers, because there's no starting and stopping point on my x-axis. And then the range of my function is the number 52. Because remember, when we looked at the graph, every single x value matched up with a y value of 52. That means every single coordinate on this line will have a y value of 52. And if you want to check, you can check in the table when you graph these kind of equations. But a horizontal line, every single y value will be 52, and that means your range is only going to include the number 52. Question 3, what are the domain and range of f of x equals negative 17? Again, f of x is just a way to write y. And this is really the exact same problem that we just did with 52, except now I have a horizontal line that's going through negative 17. But again, on the left and to the right on the x-axis, I'm continuing in both directions infinitely. So my domain for this horizontal line would still be all real numbers. Just going to try to write fast here. And then the range is going to be -17. The same concept holds true for this horizontal line that happened for the horizontal line in question 2. So whatever number our line is equal to, is set equal to, that will be your range for a horizontal line. And then our last problem, number 4, says the height of an object that is dropped into a deep valley from a cliff can be found using the function h equals 2000 minus 250t, where t is the time in seconds the object falls. What are the domain and range of this function? Well, this is actually a little bit different because we're talking about an object falling, and so it's not going to go on forever. And we're talking about distance, so I don't have negative distance. And I know that if I'm looking at mx plus b format of my equation, which is nice because I'm already in that format, it means my height are my y values, so this will be my height. T is my x value, which will be my time. Since the object is being dropped, it's starting at 2000 up in the air, and then it falls at a steady rate till it hits the ground. When it hits the ground, my y value is equal to 0. And that's important for us to remember because sometimes they don't explicitly say that in a function, but anytime we're dropping an object, when it hits the ground or hits the x-axis, that's when your y value is equal to 0. And so what I'm going to do is I'm going to take the equation that they gave me, and I can either solve it for 0, or I can go type this into my calculator, and I am looking for at what time, for what value do I put in for t that I would get a time of 0. And so we can plug this in or do it by hand. If I do it by hand, I'm just going to move my 2000 to the other side, which means t equals negative 2000 divided by negative 250. And when I do that math, negatives cancel out, and it gives me a time of 8 seconds. So this point right here is the point 8, 0. And the reason that that's important to find is because that's going to give me the range of my domain. This is the highest value of my domain, and my lowest value would be 0 here in the corner. And because we're talking about time, which is measurable, notice I drew a straight line. I didn't draw individual dots for each second. So our domain starts at 0, because time starts at 0. And then it ends at 8. So I'm going to write an inequality statement that is inclusive of both 0 and 8. So it is going to be a range starting at 0 on the left-hand side, going up to 8 seconds on the right-hand side. And then for my domain values, I need to figure out which range values match up to these specific domain values. And so when we look at 8, we know we're at 0. And when we look here, moving here, we start at 2000. So that tells me that I have a range that at the lowest is worth the 0, right? And at the highest starts at 2000 feet. And it's an inequality statement that is inclusive of both of those numbers. And so our domain is from 0 to 8, and our range is from 0 to 2,000.